Okay, section 7.3 today is about solving multiplication and division equations. Our objective for today is I can solve multiplication and division equations and apply it to a real-world problem. Very similar to solving equations yesterday, we're going to be solving these equations using an inverse operation in order to isolate our variable. So, let's talk about first a few vocabulary words. The multiplication property of equality states that when you multiply both sides of an equation by the same non-zero number, both sides will remain equivalent, or in other words, what you do to one side, you must do to the other. Let's look at an example. So we have an equation here that says x divided by, remember, a fraction also means divide, so x divided by 4 equals 4. So remember, my job is to do an inverse operation, which means the opposite. So if I have a division problem here, I want to do the opposite of divide if I want to get rid of the 4. So we're going to multiply by 4, multiply by 4. So now the 4's cancel out. Okay, these 4's will cancel out, and x is all alone, and it's x equals 4 times 4 is 16. What about the what is a multiplicative inverse? A multiplicative inverse is the product of any non-zero number and its reciprocal is equal to 1. Remember that any whole number always has an invisible 1 underneath it. For example, 2 is equivalent to 2 over 1. So let's see what we're talking about here. If we were to multiply the number 5, or in other words, 5 over 1, by its multiplicative inverse, which means flipping the fraction over, so we have 5 over 1 times 1 over 5. So how does that equal 1? Well, 5 times 1 is 5, and 1 times 5 is 5. So 5 over 5 is the same thing as 1. Okay, likewise, if we have 1/3 times 3, or 3 over 1, if we multiply straight across, we get 1 times 3 is 3, and 3 times 1 is 3. So 3 over 3 is the same thing as 1. Now, why is that important? Okay, I want to take you back up to our multiplication property of equality. If we have x over 4 equals 4, essentially, when I multiply this problem by 4, it's the same thing as multiplying by 4 over 1. So now notice that if we are multiplying this by 4 over 1, when we multiply fractions, we can always cross simplify. So if we're going to multiply this by 4 over 1, the 4 and the 4 can simplify and turn into a 1 and a 1. And now 1 times x is x. 1 times x is 1x, or x, over 1 times 1 is 1. But we also know that 1 divided by 1 is just 1. Okay, so the x will be all left alone. So we will have x equals, and if you multiply by 4 on this side, then we have 4 times 4 is 16. So the multiplicative inverse is what we use, and that is why x is left all by itself, because we are multiplying by the inverse of x over 4. Let's talk about the division property of equality. The division property of equality says that when you divide both sides of an equation by the same non-zero number, both sides will remain equivalent. What you do to one side, you must do to the other. So if we have 4a, or 4 times a, equals 12, that means that in order for me to get rid of the 4, remember our railroad tracks, remember in order to get rid of the 4, we have to do an inverse. So the opposite of multiply is to divide. So we're going to divide by 4 on both sides. So my 4's cancel, and I'm left with a equals 12 divided by 4 equals 3. Remember, 1a is the same thing as a. What I mean is, if we divide 4a, what's 4 divided by 4? Well, 4 divided by 4 is 1, which would be the same thing as 1a. Okay, but 1a is the same thing as a. So my final answer is a equals 3. So let's look at a few practice problems before we let you try some on your own. Okay, so we have 5 times b equals 30. So right now we have a multiplication problem. So in order for me to isolate the b, the variable, and get it by itself, I need to use an inverse operation. So I'm going to do the opposite of multiply, which is divide by 5. And whatever I do to one side, I must do to the other side. So now we have 5b divided by 5. Well, what is 5 divided by 5? 5 divided by 5 is 1. So we get left with 1b equals 30 divided by 5 is 6. Okay, but we have a problem here because we have a 1b. Isn't 1b just the same as b? Yes, it is. So we can just rewrite this as b equals 6. Okay, number 2. Our problem is backwards, but that doesn't change anything. We need to isolate the variable and use an inverse operation. So what we're going to do is we're going to multiply this by 6, or in other words, 6 over 1. That means we also need to multiply this side times 6 over 1. So now, if we multiply this side by 6 over 1, technically, let's look at this. If we have p times 6, that would be 6p over, what's 6 times 1? 6. Equals, what is, if we looked at these ones and we rewrote them, we would have 6 over 1 times 3 over 1. So what is 6 times 3? 18 over 1. But now we have a couple things that we need to simplify still. 6 divided by 6 is 1, so I would be left with 1p. Well, 1p is the same thing as p. And we have 18 over 1 on this side. Well, 18 divided by 1 is just 18. So my answer is p equals 18. Okay, last one. Let's look at this one. So now we have y divided by 9 equals 8. Well, my inverse operation of divide by 9 would be to multiply by 9 over 1. So I need to do the same thing to the other side, times 9 over 1. Remember, this 8 is also over 1. So now, if we have 9 times y would be 9y over 1 times 9 is 9 equals 8 times 9 is 72 over 1 times 1 is 1. Well, now I need to simplify. 9 divided by 9 is 1y, which is just y, and 72 divided by 1 is 72. So, I want you to try the next 3 on your own, pause and try, and then you will come and check them with me. If you finish early, then I will have an assignment for you to practice on Khan Academy.